Checking to see what questions you have, Peyton? Come on, you know how this works. I'm checking to see if you tried the homework.
Oh.
Yeah.
I didn't do 22. Or no, I didn't do.
Yeah, 22.
Yeah.
You didn't even try it?
No, I had it circled, but I didn't see it.
Gotcha.
What's the most you've ever won one of those?
What?
Tournament.
Like the rest of the I've ever had one?
Like the most you ever money you ever won.
I don't want a lot of them. Half the tournaments are crazy much.
Not telling her. You're not, but how about you get your workout, your homework out and start checking it?
Oh, homework. Oh,
Yeah. Oh, your life is so rough.
homework. How you been doing, Mr. Davis, Chris?
Say again?
How you been doing today?
I'm fine.
That's good, that's good.
Your
Wanna
homework
find out?
done? Trying to find it. Say again. Yes, please.
Spicy.
Come on, we should already have our homework out and be checking what questions we have. Okay.
I tried to do 22.
Check, see what I did, see if you can figure it out, or if you want to ask a question. You don't have it. Devin, did you find yours? And this is why we have an order for the notebook. Let me know if you find it. Cordell, did you try your homework?
Yes, sir. I was 22 and
12, 16.
16, yeah.
You did try your homework?
Yeah, I did number
10.
Okay. So, what questions do y'all have off of this homework? Which of these do we need to look at today to get us started with class?
22.
22? Normal one that people have asked about today. So, remember, they ask us in the directions to do what?
Oh.
What do the directions ask us to do for 22?
Grab both lines.
Graph both lines, right? So the first thing we're supposed to do here is we're supposed to graph both lines. When I look at 10 plus y equals 3x, is that a normal way to write the equation so that I know exactly what to graph? Okay, let me ask you a different way. What's the normal equation we like to have with a line? Slope-intercept, right? What is the equation for slope-intercept?
Y equals mx plus b.
Notice, in order to have slope-intercept, what has to be on its own?
Y.
Y. That y needs to be completely on its own. Right here is the y completely on its own.
Wait.
Yes.
Yes.
No.
Oh, well.
So it's got plus
10 plus y.
10 plus y, right? Notice I subtracted 10, because what's 10 minus 10?
0.
Now I have y equals 3x minus 10. Is that in slope intercept?
Yes.
Yeah. My slope is 3, y-intercept is -10. So, y-intercept is -10, up 3 to the right 1. Notice it's not just a rough sketch. I have very clear points, because every point on that line should do what to this equation? Make the equation true. And so I'm very intentional about graphing my points accurately. Now, if you're not comfortable with going from slope-intercept to the graph, what's another representation you could create? You can always make a table. I cannot emphasize this enough. It's okay if you're struggling with looking at slope-intercept and just graphing from it. But then do something else that you do know how to do, like make a table. Alright? And so every point on this line makes the equation true. When I look at 22, or the second equation in 22, is that in my slope-intercept?
No,
How do you know it's not?
because y not by itself.
The y is not by itself. So what do I need to do to get this y by itself?
Subtract 2x
Subtract that 2x.
from both sides.
Mm-hmm. Now here's the one tricky part. When I do 0 minus 2x, I do get a negative 2x. So what do we understand is being added here if it's not written? What's the only? Huh?
Oh,
If I add 1, I would need to show it, wouldn't I?
yeah.
What's the only thing we can add and not have to show it?
Oh,
A 0. Notice my y-intercept is now 0, my slope is negative 2 divided by 1. Down 2 to the right 1. Right? What's your confusion?
I thought you couldn't have a negative 2x.
Why not?
Thought you couldn't.
Because remember, we're multiplying, so that means we are repeatedly
Adding
adding a
negative 2x.
negative 2. Remember, we're multiplying by the variable. That negative 2 is what we're multiplying by, so we're repeatedly adding negative 2. But again, if you're not comfortable with that, can you just make a table?
Yes, sir.
If I plug in a negative 2, what is negative 2 times negative 2?
Positive 1. Oh, you said time? Positive 4.
What about if I plug in a negative 1?
Positive 2.
Plug in a 0.
0.
Notice how my y-intercept is 0, just like we said over there? And what am I repeatedly doing?
That's positive 2. Negative 2. Adding negative 2.
Adding negative 2 or subtracting 2. Now we are doing negative 2 times something, but if we look at the table, the pattern is repeatedly subtracting 2. There's my line. Okay? Don't forget, you will have an accuracy check on these concepts on Friday. So you should be taking notes and asking questions if you're confused. Now, because every point on each line makes its respective equations true, why is this point special?
That would be excellent. I mean, both.
That point's on both of them, right?
Yes, sir.
So that one point makes both of the equations
True.
true. Is there any other point up here that makes both equations true?
No.
I mean, if you kept going, you'd probably, well, never mind.
No.
Yeah, no, like they're going away from each other, out away from that area. It's the only point when it's at least lines. When you have non-linear things, you can get actually multiple. Devin, did you ever find your copy? Hopefully you find it later, but did you check up here in the front, dude? All right. Any other questions before we get started with today?
Number 6, but I know I did it wrong though.
Okay.
I just forgot to put it.
Okay.
12.
Okay, what about number 12?
I did it wrong.
Thank you. Looking here, what did you do differently?
Well, I tried to fully solve instead of solving across.
What do you mean?
Well, instead of minus 4 and then 4x minus 6x, I did plus 4 to get rid of it and then plus 4 on the other side.
So you added 4 here,
Yeah,
but what is 4 plus 4?
I see what I did wrong now.
What is 4 plus 4? 8, right? See how it's not making a 0? So we need to make sure that we're using the inverses to create those identities. Is that all that messed you up? Okay. I'm a little surprised no one has said 16. 16 has been one all day where everyone's been like, what am I supposed to do?
Somebody forgot to do 16.
Hmm?
Somebody forgot to do 16.
Mm-hmm. Do we need to go over it or should we skip it?
We can go over it. Just so I need to understand.
Since Shelby didn't do it, you know, we had to go over it, that's gonna be the excuse.
Call me out.
Why you gotta call her out like that?
This nigga fucking
That
away.
was
She does
rude.
all the time to me, guess.
Does she?
No, I do not. That is the biggest lie you've ever told.
I was gonna say, that, I don't think I've ever heard Shelby call anyone out. She's tried to answer questions, but she's never called a student out for something.
1/3 pi
Alright, so what are we trying to solve for in this equation?
v.
I already have V. What are we solving for? Oh, say again? No. What does it say in the problems? Rewrite the formula to isolate the variable
Oh.
R.
R.
What's the first thing happening to that R?
It's getting squared.
It's getting squared. Why am I asking you the order of what's happening?
So, can,
Cause you're gonna have to make it where R is isolated, so you're gonna need to know the order.
Yes, that's true, but
You can't just put, you know, 1/3 times V and then add the rest of it, you know, H squared, whatever, you have to actually know the order.
you need to know the order, but the reason why is because the last thing being done,
Is the first thing you're gonna do.
right, that's what we want to notice, right? So the first thing being done is squaring, then what's happening after we square it?
Times, H.
Times H, what, then what?
Divide by 1/3.
I mean, it's being,
Times 1/3.
well, first off, there's a pi there too. And then it's being multiplied by 1/3, right? Now, that is good to notice though, because that's 1, what does this fraction bar actually mean?
Divided.
Divided by,
3.
so what could we do?
Just simplify it.
1 divided by 3.
I already have 1 divided by 3.
Yeah, what's 1 divided by 3?
Oh, I am definitely not doing that as a decimal. We're multiplying by a fraction, so what can I use?
Subtraction.
No, subtraction is the inverse of what, Corel?
I forgot.
You don't know the inverse of?
Opposite of subtraction.
Division.
Yes, the opposite of
Not
subtraction.
just like, just like, adding, addition.
Thank you, addition. There you go.
I feel like that one was.
So, no, come on guys, I'm multiplying by a fraction. So I could use its what to undo it? Reciprocal. Notice, didn't we already say that we're dividing by 3?
Yes.
What's the inverse of division by 3?
21. No, I'm just kidding. Multiplication.
Multiplication by 3. Hey, I'm multiplying by 3. Right? So we want to make sure we're paying attention to, hey, I have a fraction, I'm multiplying by a fraction, so I can use its reciprocal, or just simply, hey, we're dividing by 3, so multiply by 3. So V, property of equality, I got to multiply it on the other side. So 3V is equal to pi r squared h. Now, what is the last thing being done that I might want to undo?
Times H.
The times h? So how would I get rid of or undo that?
Divided by H.
Okay, now I'll point this out. So h divided by h is 1. Is there anything else I'm multiplying by that I could go ahead and undo right now?
Pi.
So could I go ahead and divide by pi? Pi divided by pi is?
Making me hungry.
It can make you hungry, except you just went to lunch.
Yeah, but I didn't have pie.
That's fair. Especially if it's pecan pie, man. I'm always down for pecan
Okay,
pie.
I just I'm hungry and now you're gonna make me
You said
more
what kind of
hungry.
pie?
Pecan pie,
Oh,
man.
yeah, I eat that one.
Oh,
True. Or nobody.
Pecan pie is the truth, that's all I'm saying.
Homemade pecan
Alright.
pie straight from scratch.
I'm so close to being done, but do I have R completely on its own?
No, I still don't have the pie, so.
What
Big call.
is happening to the R?
It's getting squared.
It's getting squared, so what would undo that? What's the inverse?
Divide by 2.
What'd you say?
You said divide by 2.
Divide by 2.
Pretty sure division's the inverse of multiplication.
Right.
Am I multiplying here?
Well,
No, you squaring.
I'm squaring. We haven't talked about it a lot, it won't be on your test, but this is something to pay attention
what's
to.
a root?
Y'all about to say root.
Root.
The square root, specifically, right? The square root will cancel out that square, so the square root of 3v divided by pi h is equal to r.
It's a fun answer. That is.
I mean, have you isolated r? Do you know what r is equal to?
I mean,
Okay.
yeah, but I don't know that I would have thought that way.
Say again.
I don't know that I would have thought that way.
I mean, do you know what inverses are? The only part that should have been a little tricky is dealing with that square.
I don't know.
But you know what an inverse is, you know the order to do them in, you know the properties of
Just scared me
equality.
for a second, 'cause I didn't think about
And you
it.
gave me down to that one mixed it anytime you spend this.
I literally just told you that's not gonna be on the test.
I said if you did, keyword if. Keyword
The
if.
keyword is, I told you I'm not going to.
Keyword if you did. Which you're not gonna do.
Well, you know he lies a lot, so you never.
See that?
Yeah, I'm the liar in this classroom. Alright, so really quickly, we're gonna look at our objectives, and we're pretty much gonna work on 4.6 the rest of today. Really quickly, I do wanna remind you, you should already have your understanding, or your self-assessment turned into the back, right? That was something that was due yesterday. Huh? Yes, that 4.4 to 4.6. Did you fill it out? If you haven't filled it out, don't do it right now. You can do it during enrichment. We gotta do 4.6 right now. But your self-assessment was supposed to already be done. And I need it turned in today if you wanna get any feedback before your test. Right? I'm trying to give you feedback on your self-assessment. You can do it after today, except I won't be able to give you feedback if you turn it after today.
Forgot this on Friday.
Huh?
Forgot this on Friday.
Yep, we're testing on Friday. So I need it today so I can give feedback over Veterans Day and I can give it back to you on Thursday. So if you have not done it yet, you need to get it done during enrichment today. Okay? We all clear on that? Alright, but let's work diligently today on 4.6 because if we can get through 4.6, that means we can actually take some time to review on Thursday to get us better prepared for the test on Friday. Okay?
Yeah, okay.
So, let's see. Desiree, can you read the first objective for us today?
I can reason with an example each step in solving inequalities through the appropriate properties.
Alright, so remember on tests and on quizzes and everything else, what do you always have to put with your answer?
Justification.
Justification. So it's probably a good thing for us to practice reasoning and explaining our steps with the appropriate properties. That is something we need to practice so we're ready for the test on that in that regard. Alright. Devin, can you read the second objective from there? From that angle? No? A little tough? You're good. We'll be switching up groups after the test on Friday, so everyone will get new places.
I can identify the,
You good. Keep going, sir.
go ahead.
Keep going, sir.
We'll see.
I can identify the differences and similarities between solving equations and inequalities.
Alright, so we should have noticed yesterday already, do the inverses change?
Yes.
I mean, sorry, do they change from equations to inequalities?
No.
No, an inverse is an inverse. Does the order that you solve, or that you undo things, does that change?
Well, no.
Not from an equation to an equality. If it was an equation, if it was an inequality, it would still be the same order. Do the identities change?
No.
No. However, when I look at an equation, how many solutions will that equation have?
Multiple, infinitely many.
For an equation?
Oh, no.
If I say r equals 2, what makes that equation true?
R?
r equals 2.
2.
So the solution would be 2. If r is equal to negative 17, the solution would be negative 17. But if I have an inequality, r is less than 2, how many things would make that inequality true? Anything less than 2, so infinitely many. And so we want to remember that there's a lot of similarities, but there's also some key differences. One of the biggest differences is, with equations, you have to worry about multiplying or dividing by negatives. But with inequalities, with those properties of inequalities, whenever you multiply or divide by a negative, what do you have to do? So,
Like reverse the direction.
reverse the direction. I know that you don't like that language, but that's what's really happening, is you're reversing the direction of the inequality. We got to pay attention to those things. Okay, did we all finish number 6 in class yesterday? We were pretty much through? Okay, if you weren't, let me know, and I'll come and I'll look at your responses on number 6 to start. But I do want to point this out just to give everyone a good start on number 7. So Serena's checking her work with Joaquin and finds they disagree on a problem. Notice they're working together and they disagree on something. Here is Serena's work. What do you think she did to go from this first inequality to this lower equivalent inequality?
Subtracted 3,
Probably subtracted 3. 3 minus 3 is?
0,
5 minus 3 is?
2,
So far she's looking pretty good. What you want to do now is try to think, okay, one, what should she do to go from here to here, and see if you get the same answer, because that's going to tell you about who is correct, and then start to think about why is she correct or why is she incorrect. Make sense? We get on that idea? Corelli, you look like you have a question.
Yeah, I kind of do.
I mean, did she do the correct first
I
step?
understand that. It's just, never mind.
So try working it out and see if she did this correct second step
Yeah,
as well.
It's a question about if I work it out, like I'm going to get it wrong for one reason. The 3x and the -2 part, which one do you subtract first? Or add? That makes sense to what I'm
Talk
saying.
with your partner. Well, I'll come and check on you, okay?
You know what I'm saying though?
No, I have no clue what you're saying.
Alright, that's what's up. Cause I'm a failure class.
Talk with your group. I'll be there in just 1 second. Hey, group. He has a name.